So I just really want to talk to you guys about a little bit about what BCIT does with drones. My name is Eric. I am the lead of the RPAS hub at BCIT. So basically we coordinate all the drone activities across all of BCIT's campuses. So I just want to give you an overview of what happens there. In addition to that, I have a role at Indro Robotics. I'm their flight operations lead. So I kind of have 1 foot in academia, 1 foot in industry, and that's kind of the way it's been for most of my career. I actually started off in the Canadian Air Force for a couple of years. Then I actually found out what it's like to be in the military, so that wasn't that good. So I left. Then I went into geophysics, and that wasn't good either. So then I went into geomorphology. Like that was cool. It took me into the mountains and all over the Canadian Rockies and places like that. And then I sort of transitioned over into remote sensing. So I kind of combined my passion for hiking and adventure into looking at it and mapping it from above, anything to do with satellite remote sensing, crewed aircraft, and most recently drones. So I do have, even though this talk is going to be a little bit outside of the scope of the conference, I do have my heart set in a lot of things that have been presented today. So here's just a quick overview of the type of gear we've got at BCIT. We've got a fleet of about 45 different drones that we try to manage and upkeep and maintain to Transport Canada standards. Anything from the little, I think this is the, I don't want to push the wrong button. Oh yeah, maybe it's here. We've got the little Mavic Mini all the way up to our really heavy lift octocopters that have about a 90 pound all up takeoff weight. So that's well into the SFOC range of things. Multispectral sensors, thermal sensors, automated ground control points, all these kinds of things. The great thing about this gear is that it really gets used. We have a lot of research projects that I'll share with you today. Get students involved, faculty, and a lot of collaboration with industry. So it's great to actually see a lot of familiar faces here today on that note. With our drones, we give a safety kit. So I just want to make sure that you guys understand that we really try to do this safely. We don't want to be in the paper or in the news for the wrong reason that BCIT crashed a drone into something. I did actually, a colleague of mine sent a photo of a smashed window. His daughter lives in one of the Wall Center towers. A drone smashed right into her window on the 41st floor. And I mean, the window held, but it's completely, I mean, that wasn't a Mavic Mini that crashed into that window. I can tell you that for sure. So, and it wasn't BCIT, I can tell you that for sure too. So here are some of the schools that we support. So BCIT has 6 schools, kind of like 6 faculties. So anything to do with forestry and natural areas management, we support their programs with drone technology. I'll talk a little bit about what we're doing with the aerospace campus down here. Building and architectural sciences, you'll see some examples of that. Broadcast and media, but also First Nations. We've had a great privilege of working and collaborating and providing training for quite a few First Nations, which is personally one of my favorite things to do. Get out there and meet new people and see new landscapes. And one of the best things about that is they have at least as much to teach me as I have to teach them. I teach them drone stuff. They teach me how to look at the world in a completely different way. So I love bringing that back to my students and sharing those experiences with them. Here's just a few kind of examples of, I guess, some of the higher profile things that we've done through the RPAS hub. I guess we'll start down here in Antarctica. Those are my quality control experts, checking to make sure my zip straps are tight on my floaties. It's a funny story. That's a DJI Inspire 2 drone sitting there with yoga blocks strapped to the landing gear, because I showed up in Antarctica and the operations manager says, where's your floaties? I'm like, I'm not flying this over the ocean. I'm not supposed to fly it over the ocean. Well, yeah, but it's in case of a flyaway, we need to make sure it doesn't sink. So he's like, hang on a second. And he goes into his room and takes his wife's yoga blocks and cuts them up and we strap them on. I have no idea if it would have floated or not, probably not, but I wasn't going to try it out. From there, we can go over to La Paz in Bolivia, and you can see that little Phantom 4 coming down through all those wires. I was not the pilot. I was one of the local guys showing off his piloting skills. But what were we doing in La Paz was essentially providing training for the, I know it's kind of hairy, providing training for the municipal civil engineers. They have a problem with landslides and mass wasting. And they actually ended up using radar interferometry to look at those very, very subtle changes over time in slope failure, and then drones supplement that in terms of mapping the areas and getting accurate DSMs. So we were very lucky to be able. Anybody been to La Paz here? Yeah, a couple of people. Crazy place, right? Alto, yeah, muy alto. You land there at 4,100 meters and you're halfway up Everest essentially, and you can't breathe. So it's fun. And then all the way up into Svalbard, which is 78 degrees north, a place called Longyearbyen. Took me a long time to get that right. It's the most northern permanently inhabited city in the world at 78 degrees north, and I'll talk a little bit more about what I was doing up there, but just kind of give you an overview. So speaking of Svalbard, this is our, we had the opportunity to do some training for, I'm going to say these two ladies here, Sunniva Sorby and Hilda Strom. They overwintered in that uninsulated trapper's hut. The initial plan was to do a 9-month overwintering, and then COVID hit, and so they couldn't leave. So they stayed another 10 months. And what they were doing, like, why would they, what possessed them to go up there? They're trained polar explorers. One of them was the first woman to the South Pole, so they kind of knew what they were doing-ish. But they took a bunch of instruments up there and they started doing climate change monitoring, in situ for 19 months. That's an incredible research program. We usually get to go in for a week or two or a month, we're lucky, right? Sit there 19 months and collect data on an area that's experiencing not 2 degrees climate change, climate warming, but 5 or 6. Right? If you look at any of those climate change maps, Svalbard is in that 5 to 6 degree crazy, off the charts climate warming. They had some pretty high-end research partners behind them. They were doing aurora borealis observations for NASA. They were shooting rockets up there and then photographing the dispersion. And UNIS and Scripps Institution of Oceanography doing phytoplankton concentration. So we provided, along with Indra Robotics, a thermal drone that they just flew every chance they got, given weather conditions and wind conditions. And there wasn't a polar bear at their door and that they could actually get out, they were collecting data for us. We got an incredibly rich data set from a very unique spot in the world through that project. So they did these sort of monthly, I'm going to say monthly because it all didn't quite work out that way. And ice core sampling and polar bear tracking with the thermal scanner on the drone, snow depth estimation, and lots of cool data gathered in that project, which is now wrapped up. Moving on, the other polar extreme down in Antarctica. Really my question there was, are drones even useful data gathering tools in a harsh environment like Antarctica? Do they even work? Should we even bother taking drones down there for, at all? So I took my trusty Inspire 2 with a couple of different cameras, a Red Edge M multispectral, Parrot Sequoia thermal scanner, and an X7S RGB. Collected some great topographic data of glaciers. I almost want to, there we go. So this is all land here, and this is the glacier that goes up in elevation, calving off here into the bay. All of the blue that you see here is actually underwater. So it's bathymetry. And the reason, now I'm not going to make any claims of its accuracy, but the water was so clear and calm that you could just see right to the bottom through the water. So that came out really nice. One of the things that the tour operator offers is camping on the glacier. One of the problems of camping on a glacier is crevasses, right? Don't want tourists disappearing into a 100-meter chasm, right? Never to be seen again. That's just bad PR. So we can see crevasses, but we can see crevasses even better if we look at it from a certain, adjust the hill shading elements of a DEM just to kind of emphasize their location so we could do some mapping. So think about it, ship pulls in, they could send out a Mavic for all intents and purposes, do some mapping in about an hour. They've got a DEM of the surface to see if there's any undulations or any crevasses underneath that fresh blanket of snow. Maybe it could save somebody's life. So here it is. This part of the ground kind of corresponds to this channel over here. So you can see the water here. You can see these two icebergs are kind of these two little blips on here. And if I ask you to tell me where the people are on that image, I mean, for sure from back there you can't do it, but you'd have a hard time figuring out where people are. But if you look at this in thermal, and I know it's going to be hard to see, but you can see these little yellow dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 people in this image, right? Impossible to tell from RGB. So it's just the power of using a different layer of data to visualize the same thing, but get information that's unique. This is one of my favorite applications of photogrammetry, is to be able to map and actually estimate the volume of marine mammals. So these sea sausages, right, they haul themselves out onto the beach and they just lay there for hours. It's great. You can just fly your drone over them. They couldn't care less. They're 60, 70 meters above them. And you're actually obtaining in three-dimensional information about their weight and about their length. And you can estimate then their things like age and even health. It takes 4 people and a shotgun to tranquilize these guys and measure the same kinds of things. And to within 80 or 90% accuracy, we could do this with drones, but not for one animal, for like 50 animals in a single 30-minute flight. So these kinds of applications really appeal to me and get me excited about drone technology. Mapping penguins and people and seals, and here's a zodiac for scale. So, to be able to do this and throw it into a GIS and have it classify the little size dots with a certain reflectance and count them. It's about 15,000 penguins on that one beach that we landed at. Very tedious to do by hand. Of course, penguins do move a lot, way more than seals do. So there's a bit of error there. Another completely different project that we're working on is doing general visual inspection of aircraft. So take a 737 and then tell me where the defects are. Tell me where there's rivets missing, or where there's a paint missing, or a lightning strike, or a dent. So aircraft maintenance engineers take hours and hours and hours to do this. They put scaffolding around aircraft, and there's slips, trips, and falls involved. We fly a drone around it and train an AI system to look for the defects, and then that data then gets presented to the aircraft maintenance engineer and says, here's where we think the defects are. Check it out and spend time fixing it rather than looking for it. Some 3D modeling, which in itself isn't anything revolutionary, but when we do this in 3D thermal, that's kind of cool and neat, and it's definitely gotten the attention of Fortis BC and a company called RDH Consultants. So we've been working with them to 3D map not just these little 2-story buildings, but we actually mapped a 15-story tower in downtown Vancouver in thermal that's undergoing a retrofit. So it's going to one of those deep retrofits where they scrape off the envelope of the building and rebuild it because it's leaky and cold. So that was a fun exercise, flying a drone within 3 meters of windows of like multiple buildings, right? And it's like, you can't do that. That's invasion of privacy. Well, of course you have to give notices and people have to be made aware of it. So if you think it's impossible, just think of a way of doing it, right? But people do have to cooperate. Gas sniffers, this is really the thing of the talk, which if you guys go around tomorrow, we'll be demoing this exact unit here out in the field. So that'll be much more exciting than what I can talk about here. But here's, oops, whoa, back up. No, don't want to give everything away. Hang on. This is the little gas sniffer up here. If you saw Maya at TurnTech, she's got it mounted there on the M300. We were doing some testing with it out at BCIT. And a very cool sensor. It has the capability to map or to detect all of these different gases, but only about 8 or 9 at a time. So you have to kind of choose and pick which ones you're interested in. And they build a sensor with that combination of gases. So it does PM1, 2.5 to 10 at 1 microgram per cubic meter. The electrochemistry for gases has a 1 part per billion resolution. Photoionization process is for volcanic organic compounds, and it does also a non-dispersive for hydrocarbons, the likes of which methane and things like that. So it's a very, very capable process, and you can do it in real time. You can put a SIM card into the sniffer and have it through the cellular network display on your screen real time the mapping of the dispersion of the gases, or you can look at it after. So here's our survey around BCIT, and got some hits of methane over here. And you can see the 3D nature of that survey as well overlaid onto the campus map. Last thing I'll talk about here, completely off top. You can see how schizophrenic my drone presentation is. It's just all over the place. Because I like to test new technologies, like to stick my fingers where they don't belong, but not into this thing because I'd lose them. Have you ever seen a chainsaw dangling off a drone? No? Sounds like fun, doesn't it? Right? Yeah, sign me up, right? So there's a company in Quebec called Deleuze. Yeah, get it? Deleuze. Built this thing for their own purposes. They're a research unit at I forget which, is it University of Montreal, I think? Yeah, and they were so successful, they had so many orders for it that they just like, screw this, we're gonna make this company and make these devices, right? So it's literally, it's more of a glorified nail clipper than a chainsaw, honestly, but it does have these very menacing claws that grab onto a branch. And then there's a saw blade right here, think of a Dremel tool type of thing, that then chops the branch off a tree, top of a tree that you want for sampling. So imagine you're doing all this multispectral mapping or thermal mapping or hyperspectral mapping of your site, but you don't really know what the pixels, ground truthing, right? You need to connect the values of the pixels with what's happening in the field. So you go there and grab your chainsaw, you snip a branch and you say, okay, this is what's happening, on a phenological level, and here's what's happening with the pixels. So we got to fly this thing and train the crew on how to use it. So here, it's an interesting takeoff procedure because these are rigid poles. These are carbon fiber tent poles. So imagine if the drone's going up, this thing's getting dragged, right? And so you have to kind of do this like takeoff arc procedure. It's quite neat. Anyway, great fun. But through all of this experiences, I really found out that drones really are fantastic data gathering tools. And I think a lot of the presentations here have also discovered that element. But not for everything. Drones aren't an end all be all. They are an amazing tool in your toolkit, right? For a lot of things that we can think of that we could do. So that's been an amazing path to being able to answer that. Incredibly collaborative. As I said, we've collaborated with all 6 schools at BCIT. We've had students from the medical field, from building science, from engineering, so it's really been an incredibly collaborative and an experience that's brought a lot of different students together and worked on projects that they normally wouldn't otherwise have had the opportunity to do. And also that bridge between academia and industry has been fantastic. So, looking forward, we're still trying to figure out which LiDAR unit we want at BCIT. We're really want to get into more of the radiometric thermal models, so actually be able to pull out those individual temperatures out of that nice looking 3D model. And the idea of getting into ground penetrating radar, those are things that we're kind of looking forward to. So thank you for your attention, and I think this is the last slide here. Oh no, we're done. Okay, great, thank you.
got a question?
Yeah, I got a ton of questions. That was fantastic.
Thank you.
Just so inspired. Is the mic on? Yeah, the mic's on. Yeah. Snipping off the tree branches. I saw a geochemistry talk years ago in Manitoba where they were going around collecting small little spruce boughs and then analyzing them chemically to find copper. Yeah. Okay. Yeah. You guys know. So there's.
He does it from a conventional helicopter. The guy straps himself in.
That sounds way more fun.
He aims over and he says, "Yeah, this thing is way more safe, maybe." Rob Skagel is the guy that does it. Yeah. Sorry.
And you get nice images of copper dispersions and,
Oh yeah.
and zinc dispersions.
Metals of any kind. The trees uptake all the metals.
Yeah, exactly, yeah. Yeah.
Mhm.
What
Yeah.
was it?
That was a great talk.
Thank you.
I love the picture of the seal.
Yeah.
You know, that you were able to kind of get that three-dimensional effect and sort of see the translucency. What data were you actually using in that?
In terms of capturing the data,
Yeah, so what?
it was the ZenMuse X7 payload on the DJI Inspire with the 50 mil lens. So that was an equivalent 75. So you have a very, very small footprint that you're taking. So it's quite a long focal length. So photogrammetry.
Okay, thank you.
Maybe that's the question. Yeah. Yeah.
Any other questions? You want one? Very good talk.
All right, great.
Yeah.
Thanks for having me.